Hey folks, so I want to show you some of these atomic emission spectrums. So what I have are a few power supplies, and they say danger, like high voltage, don't put your fingers in here. So we'll try not to do that. And then in them are these glass tubes. Here's one that I am holding. This is a tube filled with hydrogen, and it just is a long glass tube. And then it goes into the power supply like so. Get it in the right spot. There she is. Okay, so I've tried this a couple ways, and I can't get the perfect camera to show you exactly what I want you to see, but we'll do our best. Okay, so what's going to happen is I flick this switch, I'm going to turn on the electricity, and it's going to serve as a source of energy. And we talked about the fact that if we add energy to these electrons in their ground state, the electrons can jump to a higher energy level, and each specific energy level in the atom contains a specific amount of energy. So depending on how much energy the particular electrons are gaining, they can jump 1 level, 2 levels, 3 levels, and when they're up in a higher energy level, we say that the electron is excited. Now, the excited state is never stable. High energy is always unstable, so the electrons want to fall back down to their ground state. But in order to do so, they have to release energy in the form of light. And depending on how much energy was gained, that'll determine how much energy is released when the electron falls from the excited state back down to the ground state. So for example, if I just kind of turn on this tube, and I have the lights on right now, but I don't know if you can kind of tell that it's glowing like a pinkish color. And so right now I see pink, but really that pink color is a combination of a whole bunch of different wavelengths of light that are all being emitted by the electron in the hydrogen atom. Now, this tube contains millions and millions and billions and billions of hydrogen atoms. But what if I want to separate that light to see all the different wavelengths of color, all the different bands of color that are characteristic of excited hydrogen electrons? And so for that, we use this. Prism glasses. Usually this in classes is a hoot. And so we put on these special prism glasses. Maybe if you've taken physics or physical science, you've used like little glass prisms, but these do the same thing. So these special goggles or glasses will separate the light that I see into the different wavelengths of color. Now I'll try to show you that with these guys. So here's another set, and I'm going to put them over the camera and see if it'll still work. It's not perfect, but it might do the job. Okay, so first thing we want to do is shut off the light. Lights are off, and then just make sure that this thing is kind of working. So right now on my screen, get out of there, there's a ton of light being emitted, and most of it is maybe white light. So if I put the prism over my phone, do you see little rainbows around the edge? Or here's my, will it work? Oh, look at that. Here's the phone over here. That anything that's emitting white light is really emitting a combination of all colors of the rainbow. Kind of like that first picture, that if I run the incandescent white light through a prism, it should separate into a perfect rainbow. Now, I don't know if I saw the whole Roy G. Biv, but it was close, right? Yeah, that's a rainbow on the outside. Okay, so now we talked about hydrogen. That hydrogen is supposed to emit kind of this purple light. But when I run that through the prism, I should see different bands of color. So according to this diagram, there's maybe kind of a red band, a teal band, maybe a blue or purple band. And we're going to try to see that with these prism glasses over the camera. So now with the lights off, if I turn on this tube, there's my purple light. And so I'm going to put this over the camera. And can you kind of see evidence of different colors? There's the red. Oh, there's kind of a good one. There's the red. There's kind of a teal. There's blue. And again, it looks a little bit crazy, but I'm at least seeing evidence of different colors of light, which correspond to different wavelengths and frequencies. all together without the prism, I'm just seeing a mixture of all of those colors. So yeah, it looks kind of like a pinky purple color. But that's because there's red and teal and like a purpley blue, violet, kind of cool. And so what's happening is the one little electron in the hydrogen atom, and again, there's millions and billions and billions of hydrogen atoms in this tube, it seems to make characteristic jumps up and down the energy levels. Sometimes the electron makes a low energy jump, and then it releases low energy on its way back down to the ground state, and that's when I see kind of that red band. Sometimes the one electron makes a bigger jump, jumps up maybe 2, 3, 4 energy levels. So when it falls back down to the ground state, it releases a higher energy color. But notice that there are specific wavelengths emitted from hydrogen, and this pattern, which I guess you can kind of better see up here, this pattern would be characteristic of hydrogen. No other element would produce the exact same pattern of colors. Okay, so that one was hydrogen. Here's neon. So here's a tube of neon gas, and it glows really bright orange. So if you're talking about a neon sign, it's really only filled with neon if it gives off this characteristic orange color. Now other signs glow in different colors, but then they're either filled with a different gas or there's some kind of like a colored coating on the outside. So let's see what happens if I put the prism on the outside of this one. I don't know if I'm getting too much. But usually you'll see, I mean, lots of red, orange, yellow, but there's also a little bit of green sometimes that'll come off from the neon. Obviously, without the glasses, I just see a combination, and that was like crazy bright. I don't know if I'm even seeing the different bands of color. But I should be able to see like specific red bands, orange bands, yellow bands, and there's usually even a green band. Without the glasses, I just see a combination. Okay, so there was neon. This one's mercury. So it glows kind of like a characteristic blue. And then with the glasses, oh, that's not bad. You usually do see like a lot of dark blue and purple, violet colors, which they're beautiful. But then there's also a little bit of green and maybe a little bit of orange in there. Who would have thunk it? Right? I mean, without the prism, you just see a combination of all those colors. With the prism, I can break it into the specific bands of light, the specific wavelengths, energies of light that are being emitted. Now, without the glasses, what's kind of interesting is that I can see the bluish color of the mercury as opposed to like the orange color of the neon. And if I were asked on average, which element has electrons that tend to make bigger jumps up and down the energy levels? I'm looking for the one that's emitting on average more high energy colors. And so then I'd be going with the mercury. I see more of the like blues and violets and even like a little bit of, there it is, even a little bit of that cool green color. But on average, these are higher energy colors as opposed to maybe like the reds and orange and yellows that I would see from neon. All right, let's see what else I got. I've got some argon. Argon too is kind of like a purpley color. Sometimes headlights are filled with argon gas. If you're ever driving and you go past somebody that's kind of got like these tinted headlights, they could be filled with argon. And it's kind of cool. Like you do see a lot of like the purple, the violet, a little bit of yellow, orange, red. And it's just kind of cool then that when I take away the prism, I see a mixture of all those colors. But the prism tells me what's happening to the electrons. Some electrons are making small jumps, and I'm seeing those low energy colors. Some electrons are making kind of big jumps, and I'm seeing that higher energy violet color. Same thing usually happens with, let's try, my last one is nitrogen. I think nitrogen almost looks close to white light. Like, I mean, if you look in the middle, it's got like a little bit of a pinky orange tint to it. But if I run it through the prism, you usually do see almost every color. Like I'm seeing a little bit of the blues and violets, the yellow, maybe a little bit of green, some orange, some red. So it's close to white light in that it is emitting almost all the colors of the rainbow. But all of these colors too can have different shades depending on the exact numerical wavelength and frequency of the light. And these specific patterns of color would be then specific to neon. We call it the bright line emission spectrum.